Alright, now dear children, we go to the next topic after the first law of thermodynamics, that is applications of first law of thermodynamics. Means we are almost in the last part from this chapter. Okay, now there are many applications that we see of first law of thermodynamics. Okay, and this application can be understood under the different processes. Under what different processes? Okay, and the system also. So we start with the first application, that is under isolated system. Now, first law of thermodynamics can be written under isolated system. Now, what is isolated system? Just try to understand. Isolated system means a system which can neither do work nor take or give any heat from outside and give heat to the outside. So that means such a system where there is no exchange of heat. Okay, there is no exchange of heat between the system and the surrounding, and there is no work which is done by the system, and such system is called isolated system. So isolated system means a system which can neither do what? Do work nor take what? Or give, not take or give heat from or to the outside. Now to the outside means usually to the surrounding. In a simple word, I'll tell you that there is no exchange of heat between the system and the surrounding. If there is no exchange of heat between system and surrounding, and without doing any work, okay, by the system, then such system is called isolated system. Which means for isolated system, there is no exchange of heat, means the total heat will be 0. So Q is 0, and even this system does not do any work, means work done is also 0. Means Q is 0, W is also 0. So if Q is 0, then W is 0, then we can write on the isolated system the first law of thermodynamics. And the first law of thermodynamics is given by the relation, and you know relation is Q equals to delta U plus W. See, Q equals to delta U plus W is the mathematical relation of first law of thermodynamics. So in this relation, let me substitute the value of Q. Q is 0 equals to delta U plus W is also what? 0. Which means delta U is also 0. Delta U is also what? 0. That means the change in internal energy will be 0 in a system, and this system is called isolated system. So children, remember this part. What is the change in internal energy of the isolated system? That is always 0. So if change in internal energy 0 for what system? Isolated system, then under this system U remain constant. That means the internal energy remain constant. So in which process or system the internal energy remain constant? That means under isolated system. So remember children, under isolated system the internal energy remain constant, means the change in internal energy becomes 0. And this internal energy change in internal energy becomes 0 is due to the heat. There is no heat exchange between the system and the surrounding, and there is no work which is done by the system. So that's why such system is called isolated system. Okay, so this is number 1 application of first law of thermodynamics. Now we have number 2 application, and this application is under the process, and this process is called isochoric process. Isochoric process. So next process in which the first law of thermodynamics can be applied is called isochoric process. And children, this is such a process, okay, in which there is no change in volume takes place. Okay, that means this is a process which takes place at a constant volume. That means the volume remains constant. Volume remains what? Constant in this process. So the process in which the volume remains constant is called isochoric what? Process. Okay, which means there is no change in volume. There is no change in volume. Now, no change in volume means delta B becomes 0. Delta B becomes 0, that's why B remains what? Constant. And such process called isochoric process. So when there is no change in volume means definitely there is no work is done by the system. So remember children, in this process no work is done by the system. And you know why no work is done by system? Because you know we have done it. Work done by the system is given by P delta B. So we have derived the expression of work done by system is because W equals to P delta B. Okay, or we can also write this as P B2 minus what? B1. The change in volume is 0, that means work done is also 0. So and this process is called isochoric process, which means when some amount of heat is added to the system, this means there is no change in the volume of the system, but the pressure and the temperature changes. Volume does not change, but pressure and temperature changes. Okay, pressure and temperature changes. So under this process also we can apply what? First law of thermodynamics. And you know first law of thermodynamics can be expressed by the relation first law of thermodynamics. And the first law of thermodynamics can be expressed as a relation which is given by Q equals to delta U plus W. So under this case W is 0. So I write Q equals to delta U plus 0, because under this process no change in volume, that's why no work is done by the system. That means W is 0. If W is 0, then Q equals to what? Delta U. Q equals to what? Delta U, which means the entire heat which is given to the system, see the entire heat given to the system is used in increasing the what energy? Internal energy of the system without doing any work by the system. And such system is called, such process called isochoric process. So children, remember this part. Under isochoric process, the entire heat given to the system is used to increase the internal energy of the system. That's why Q is always equals to delta U. Now there are number of examples that we see under isochoric process. Now to tell you about the example, okay, explosion of petrol vapor. Petrol vapor explosion is also comes under what? Isochoric process, because whatever heat that is given to the process, okay, is completely used to increase the internal energy of the process. When there is a change in internal energy, then there is a change in what? Temperature. Okay, this is basically when the system comprises of what? Gas. Okay, so the explosion of petrol vapor and air in petrol engine is also one of the example of isochoric process. Similarly, another example you can see is that during the explosion, just before the power stroke, the volume remain constant, and there is a what? Sudden increase in the temperature and the pressure without changing the what? Volume of the system. Okay, and such process called isochoric process. That's why explosion of gases is one of the example of isochoric process. So simple example of isochoric process is explosion of gases comes under what process? Isochoric process, where the temperature increases, okay, whether without changing the volume of the gas. Now this is number 2 process. Now we go to the next number 3 process, and that is called isothermal process. Now isothermal process is a process in which the temperature remains constant. So remember children, isothermal, thermal means related to heat, and heat is comprised, the degree of hotness is given by the temperature. So when I use the word isothermal process, means the temperature remain what? Constant. So which physical quantity remain constant in isothermal process? Temperature remain what? Constant, remain constant. So in this process, the temperature remain constant. So that your value of Q means what? The amount of heat, W means the work done, and the internal energy may change, means all the quantity may change. But if I take a system as a gas, and that gas is also what gas? Ideal gas. What gas? Ideal gas. Means ideal gas means those gases, okay, which is theoretically considered, okay, and these gases follow the law known as Boyle's law, Charles' law, gas equation. These are called ideal gas. And children, the details of ideal gas you learn in the chapter Kinetic Theory of Gases. Okay, but in case of ideal gas, so for ideal gases, okay, the internal energy, as you know, depend upon the what? Temperature of the gas. So for system like gas, okay, change in internal energy depends upon the temperature. Depend upon the what? Temperature. This point you need to keep in mind. So when the temperature remain constant, the internal energy remain what? Constant. This internal energy, change in internal energy remain what? Constant, which means delta U become 0. That means this is true for ideal gases as a system. Okay. Now under this process, isothermal process, and for ideal gas as a system, there is no change in the what? Energy, internal energy of the system. So under this case also we can write the first of thermodynamics, and the first of thermodynamics given by Q equals to delta U plus W. So Q equals to delta U is 0 plus W, which means I write on Q equals to W. Q equals to W. But remember children, this relation which I have written, the first of thermodynamics as Q equals to W, is true only for ideal gas as a system under what process? Isothermal process. Now this relation simply says that the amount of heat energy absorbed by the gas or given to the gas is completely used to do work done by the gas. Is completely used to do some amount of work done by the what? Gas. So the heat energy given to the gas is completely used by the gas to do some amount of work done by the gas. This means Q equals to W. And children, the details of this isothermal process, the work done by the isothermal process, and all you learn in the next chapter after this thermodynamics, okay, chapter, okay. And that time also we use this condition only. But remember this part, for ideal gas as a thermodynamic system, okay, the amount of heat, the amount of what? Heat energy, okay, given to the ideal gas is completely used to convert into work done by the gas without increasing the internal energy of the what? Gas. So this is the explanation of isothermal process, one of the application of thermodynamics. Okay, first of thermodynamics. So there are still two more processes to discuss, and that you learn in the next YouTube video.